Bert Jan is co-founder of OpenValue. Most of you will know him as a speaker on many international conferences. Also he's a Java champion, JavaOne Rock Star speaker, winner of the JUG Choice Award, etc., etc. But he's really someone who is at the center of the Java community and likes to contribute in many ways. So we're very happy that he's joining us this evening. After the break, we will have a second talk, more about that later. But for now, first the floor is to Bert Jan. Bert Jan, take it away.
Thank you, Gerrit. Well, I'm abiding to Corona regulations as well, because I'm a couple of 100 kilometers away from you, currently quarantined in my home because my kids contracted Corona, but they're all fine. So the next 30 or 40 minutes, we're going to talk about software architecture and about DevOps. And these are basically my two favorite topics to talk about. So let's start with, I don't need to introduce myself anymore because, Gerrit basically already did this for me. We're going to be looking into, a couple of topics in the next couple of minutes. I don't see my slides yet in the screen, Gerrit, so if you could fix in the stream, if you can fix that, that would be great, so the other people can see it as well. So the next, let's say 45 minutes, we're going to look at an introduction. I'm going to explain what's basically the base principles behind DevOps. I'm going to explain you why I think that you should do DevOps, and I'm going to share the principles of DevOps. And next, I'm going to plot these DevOps principles to the principles of software architecture. So how you can apply software architecture in a DevOps world.
Bert Jan, could you maybe hold on for a couple of seconds? We're trying to fix the screen. Oh, it's there, I think. No, it's there. Okay, take it away. Sorry.
Well, you said a couple of seconds, so those couple of seconds are over now. And in the end, I'll do a short stint about flexibility in software, which is a story about a project that I lived through a couple of years ago. And every story needs an end, and this one is no exception there. There's room for questions afterwards. If you have any questions during the talk, feel free to drop them in the YouTube chat. If you have any questions afterwards, you can reach out to me on Twitter. I'll be happy to help you out there. So let's start with the first question. What is software architecture? How can we define software architecture? And you could say that it's the sum of all decisions you've taken during development. You could say that it's about making design decisions about important stuff. So then what's this important stuff? Well, it's typically the stuff that you hope that you got right in the first place when you start the project. And I'd say that it's about enabling a team to build software that provides solutions for business problems. So in the end, the goal of architecture is to allow a development team to help the business accomplish their goals. So let's look at a couple of definitions first. So continuous integration is where team members integrate their work frequently and their commits are verified by an automated build and test suite. So think for yourself, do you think that you practice continuous integration in your current project? Okay, now think again. You're doing CI, according to my definition, if all developers in your team check in to version control at least once a day. And you're doing CI, in my definition, if every check-in triggers a build and a unit test run. And then finally, you're doing CI, in my definition, when if the build fails, it's not fixed within 10 minutes when it breaks. So now think again, are you doing CI or not? So this is why definitions matter, right? Then continuous delivery, and this is basically a way of working or way of practicing software development. Let's say that it's about building and testing your software in such a way that it's always in a releasable state, so that you're ready to release to production at any time. And then maybe the next step is continuous deployment, where every change that goes to your CI pipeline and to your automated test suite automatically gets put into production. So is this the end goal for everyone? I wouldn't necessarily say so. It is obviously a good goal to strive for, because then you're basically doing lots and lots of small changes instead of infrequent big releases, but it's not necessarily the end goal for everyone, I'd say. So most teams I work with deploy their stuff to production every sprint, so every 2 weeks or so, and that's fine for most people as well. And then DevOps. What is DevOps? It's kind of hard to find one coherent definition of DevOps, so I have a couple for you. So you could say that's about devs and ops, and they're being responsible together. So it's about taking responsibility as a team for the entire life cycle of a product. So it's about being responsible for moving from idea in your head to working software in production. Another definition you could say is that it's about developers and other IT professionals. So testers, or maybe the project manager or UX designers, and they're working together on a shared goal. And this goal is building and running good software quicker and more reliable. Or there's another one, you get 3 for the price of 1 today. This is a more goal-driven definition. That says DevOps is a set of practices with the goal to reduce the time between committing a change and the change being placed into production, while ensuring quality, obviously. So the time between commit and that is live with sufficient quality. So why should you do DevOps? It helps making your business win, making your business move faster as an enabler for continuous delivery, faster problem resolution, and also the ability to focus on adding value instead of resolving problems. So what's it really about? What's the core of DevOps? Well, I'd say it's mostly about culture. It's a cultural thing. And this is a culture of freedom and responsibility. So freedom is nice, but the price you pay is responsibility. So take responsibility, trust your teammates, and design a system in which people are held responsible for the consequences of their actions. So it's not about blaming whenever something goes wrong. Whenever something goes wrong, it's about getting together as a team, looking what did we do wrong as a team, and what do we need to do better next time. As Werner Vogels, the CTO of Amazon, says, you build it, you run it. I think mostly DevOps is about empathy. So empathy means being able to place yourself in somebody else's shoes and experience the world from their viewpoint. So DevOps means giving enough about your job to want to learn all the parts and not just your little world. Empathy allows you to see other teams as enablers rather than as blockers. So be likable, be approachable, and get stuff done. I'd say that's DevOps in a nutshell. So what are the principles of DevOps? Well, I'd say there are lots and lots of principles, but these are the ones that I find particularly important. So gradual changes. Focus on customers. Automate stuff. Having ownership over a product you own as a team. Collaboration. Experimentation. And continuous improvement. So next we'll dive a bit more into these principles and map them to the world of software architecture. So if you look at the principle of gradual changes, so no big releases, but having small incremental changes continuously into production. How does this map to the software architecture world? I'd say that it's about not trying to get everything right in the first time, but it's about starting with the simplest solution you can come up with. Obviously, software needs to be future-proof, but it's also obvious that we can't predict the future. So start with the simplest thing that can work, get this in production, and start getting feedback from your end users. And improve and refine along the way. Typically, it's you learn more by gaining insights over a period of time than thinking a lot upfront. And focus on dealing with uncertainty. So whenever, as a software architect, I need to make decisions, I try to focus, think about short-term and long-term effects. And things that have high uncertainty and high risk is something you need to look into right away. Things that have high uncertainty but low risk is probably something that you can pick a solution and go with that right away and see whether you need to change something along the way. So try to deal with high uncertain and high risk issues first, and the other ones plan them or postpone them and deal with them whenever you need. And as a result, I'd say my general advice is to do just enough architecture to get through the next sprint. So don't do any big upfront designs. Obviously, you need, when you start a project, you need to think about the general architecture, the components of your system, how you deploy stuff, how you're going to run stuff. But there's no need in designing everything in detail. Do just enough architecture work so the next sprint can deliver what they need to deliver. Then the principle of being customer oriented, and this is an interesting principle for architecture, right? Because software architects typically have not much direct contact with customers. So if we apply this to the world of software architecture, I'd say focus on the business needs. Your goal as a software architect is to create something that's buildable, that can help the customers reach their goals. Don't design for yourself. Don't design something because you like it or because you think this is a nice other technique to try out. Design something because it's something the customers needs. So it's something that can help your business accomplish their business goals. You don't design architecture for you. You design architecture for, in the end, something that a team can build, that your end users can help to do their work better. And help out business with clarifying non-functional requirements. So stuff like it needs to be secure, or it needs to be performant, or it needs to be scalable. This is typically quite hard, right? Business people typically have trouble defining these requirements. And as a software architect, you are right between the team that builds stuff and the business that comes up with these requirements. You can help them clarifying. What do you mean with it needs to be quick? How fast does it need to respond? How many users do we expect? How many requests per second? Do we need to be able to scale, or do we have a continuous load? Security, how secure do you want it to be? Do you want to be, I don't know, be able to withstand a break-in attempt to a data center? Okay, then we might need to encrypt stuff. So I think this is where you can really, as a software architect, prove your worth to a business by helping clarifying these types of requirements. Automation obviously is a big part of DevOps. If you automate things, you can be sure that they work in a predictable and repeatable way. So what can you do in terms of automation in software architecture? Well, obviously there's the tools that you can use for diagram generation. If there's one thing I think important for drawing diagrams as an architect, is they need to be maintainable. Same as with software. If you draw a diagram in some tool, you export it to a PNG file and upload it to Confluence, and somebody needs to make a change there, nobody's going to do it because they don't have the tool, they don't have the source files. But if you use something like Plant UML or Structureize or any tools that support UML or the C4 model, then typically it's a small step to edit something because there's a code definition of your diagram, and it's something that you can easily update. There's automated architecture checks that you can use, for example, by using tools like ArcUnit that continuously validate, for example, the architecture of your system, that there's no communication between components that are not allowed to communicate together. You can run automated analysis on stuff like coupling and maybe even cohesion. And there's tools that can well help you calculating technical depth, but also stuff like duplication, etc. So focus on getting as much as possible of these automated architecture checks in your CI pipelines. And an infrastructure as code is something you can use to also automate your architecture, but then I'd say it's less about software architecture, but more about cloud architecture. So if you design your system to be run in a cloud environment, then obviously it's helped by automating the provisioning of these environments, because this also allows you to make sure that all your environments are configured in the same way, instead of the problem that it works in acceptance but not in production because something was just not configured in the same way. Ownership then. If we plot this to the world of software architecture, I'd say that the team that's responsible for the application also owns the architecture. So the team is also responsible for the architecture, and the team should also be able to make changes to this architecture, maybe by consulting with a software architect, but in the end, the team that's responsible for the application should also own the architecture of the application. And as a direct result, the architect needs to be involved with a team. So typically in a DevOps world, you have cross-functional teams, which means that a team has all the capabilities it needs to go from idea in your head to working software in production. And it means that the architect or whoever works on software architecture needs to be involved with the team as well. And you're accountable for the end result as well. What I've seen happen is that somebody designs an architecture, throws it to the team struggles by getting it to work because the architecture is rubbish. Then they fail with the project, and then the architect screams, well, but you didn't implement my architecture correctly. Well, if they didn't implement the architecture correctly, then you weren't there to help them implement it correctly, right? So I'd say that you're just as accountable for the end result as everybody else in the team is. And one thing that's more of I'd say a general piece of advice in every fast moving world is to minimize any dependencies to anything outside the team. Because as a team, you can control everything that's within your span of control within your team. So your code base, hopefully your infrastructure, etc. If you have a dependency to anything outside your team, something you cannot control, if there's anything wrong there or you need to wait for something, then you have less influence or maybe even no influence on fixing these kind of things. So try to make sure that as a team, you don't depend at all on any things outside your team. And it's also is a direct reason for why the architect needs to be involved with the team as well. If you need to wait for an architect outside the team to design something before you can build it as a team, I'd say that's a pretty unwanted dependency you have there. So this is a diagram from Gregor Hope from the website architectelevator.com, which is lots of interacting architecture viewpoints and articles. And he says there are basically 4 models of architects working with teams. So the first one is where the architect decides and the team executes. The second one is the architect is in the team, working directly with the team as a separate role. The third one is team members do architecture. And the fourth one is there's implicit architecture or no architecture at all. So you see 2 green check marks. And the point with these 2 green check marks is that there's arrows both ways. So there are feedback loops between the team and the architect, or architecture is even done by team members. And this is fine, because then there's less dependencies outside the team. You can quickly make changes to your evolving architecture. If there's no architecture, then it's going to be chaos. It might work for small projects, but for any reasonably sized projects, it won't work at all. And then there's the first one where there's an external architect making design, giving it to the team. I say that this could work, but then there needs to be arrows up as well. So there needs to be a feedback loop from the team to the architect, and they still need to work together. And in the end, you'll end up more in the area of the second diagram here. Collaboration. Apply this to software architecture. Well, that makes sense, right? You need to collaborate as a software architect. So talk to all stakeholders. Try to get an idea of why are we building this system that I am designing. And mind you that developers are stakeholders as well. Infrastructure experts are stakeholders as well. Your business and management, obviously. But in the end, these are the people that are going to build upon your architecture. Be transparent as a software architect. Explain decisions. Explain why do you want them to do this in a way like this. And be open for feedback as well. If you design something and give it to the team and they don't agree, and you say, just do it and don't explain why, there's one thing sure, they're going to do everything they can to go around you and do it in a different way. So explain and try to get support from your team on why they're working in a way like this. Maybe there's some constraints that they're not aware about. Maybe there's some dependencies that they're not aware about. And obviously here there is no room for ivory towers. So in an ivory tower, I mean that you're working in your architect office and from there sending your designs over email to a team. Obviously you need to be collaborating with the team as well. And try to get stuff like non-functional requirements as clear as possible as early on in the project, because it can have a major impact in your architecture, especially nowadays with cloud native stuff and microservices. Stuff like resilience is more important than ever. So here also talk about the people who need to run your architecture in the end, whether it being a DevOps team or maybe an infra or SRE team. There's SREs are stakeholders as well. Experimentation then. Do proof of concepts, even as an architect, to gain insights. So if you're not sure about something, there's a couple of things you can do. You can keep thinking until the answer pops up, and that typically doesn't work. You can just try something and try to get feedback from the team whether this works. This might work depending on the situation and whether there's risk involved or not. Or you can try to do an experiment yourself or have the team do an experiment. So in my experience, every hour you spend experimenting with something saves you at least a day in development later. Because the easier and the earlier you gain these insights, the more early in the process you can steer based on the knowledge you gain from these experiments. Try to solve problems early, obviously, but also know when to postpone solving problems or designing things. So if you design upfront for only one sprint, then after the sprint, you're throwing away maximum one sprint of work, right? So embrace failure, embrace trying out something in a sprint, getting it live, and then finding out that it doesn't work at all. You're throwing away 2 weeks worth of work. Well, that's a shame. But if you wouldn't experiment there and you would have built on this for 6 months, you would be throwing away 6 months of work. So it's okay if something turns out not to work, as long as you find out reasonably quickly. So don't be afraid to start over. Not the entire project, but an iteration worth of work about a sprint. This is a post on LinkedIn, I think, from Gurgly Oros, who well, is a fan of experimentation, and he posted a post about an idea of using RFCs, so a request for comment, to get feedback on designs. So he would kind of make a design and then send it out to loads of people in the company and ask for feedback. So somebody read this post and pitched this idea to their chief architect, and the architect said, it sounds wildly inefficient sending something like this to more than a small closed group. So this person asked Gurgly, like, how does it work in practice? And then Gurgly said, well, for one, we did not have a chief architect who shot down ideas without trying. So experimentation means trying things and finding out the results. And even if you don't like these ideas, or if you don't like the results. So sometimes in companies, you want to try something, somebody asks you, can you make a business case for trying this? And that's obviously hard, right? Because you don't know the results up front. But you can turn this around and say, no, make a business case why I should not try this. And if there's no answer, then go ahead and try it and incorporate the feedback in the next iteration of your design. And then the principle of continuous improvement. Focus on feedback loops. So focus on getting feedback from whoever is doing something with the architecture you designed. Getting feedback whether does this help solve business problems? Does this help developing features quickly? Does this help with building maintainable software? Does what I designed actually help the team to build software in a better way? Ask developers for feedback on these type of subjects. And measure and monitor. So there's lots of things where you can measure speed of code changes, issues, defects, response times in production. If you design the system that's highly scalable, then I will be really interested in seeing the response times and scaling behavior of the application once it's running in production to see whether what you design is actually working. And if you find out that's not working at all, okay, back to the drawing board, but at least you know. And try to focus on creating an evolving architecture instead of a big upfront design. And this is a big difference with traditional building architecture, because their evolving architecture doesn't work that well, right? You've built like 4 floors of a skyscraper, and then you think, okay, I'm going to now start building with wood instead of steel. Well, that doesn't work at all. But with software architecture, it's very easy to throw something away and start building right away. I'd say that this is all goes back to the point that I made about designing just for the next sprint. Try to continuously get feedback on, is this working? Are we moving in the right direction? Do we have any risks or thoughts about things we should change? And try to keep working on your architecture and keep evolving every day. So yes, obviously you need to do some upfront design, but try to do just enough and then move along the way. And as a result, software architecture is never finished. It's a continuous process. I think Patrick Dubois, who's one of the people who first coined the term DevOps, he said, after continuous delivery comes continuous re-architecture. Because also your architecture is something that needs to stand through the tens of time and continuously improve with whatever is happening in your project. So I see some questions coming in, which is great. Keep them coming, and I'm happy to answer them after the talk. So then I see some of you thinking, well, it all sounds pretty cool, continuous delivery and DevOps, but it won't work here. So this is from a talk by Jess Humble, who's one of the original authors of the continuous delivery book. And in this talk, Jess gives a couple of examples of typical reasons why software architecture, why DevOps or continuous delivery doesn't work. So the reasons that people state is, well, we are regulated, so we can't do DevOps. Well, the Amazon cloud is regulated. They have the Gov cloud for the US government, and they're doing a gazillion deployments per day. So if Amazon can do it, then probably your small regulated organization can do it as well. We're not building websites. Well, that might make stuff a bit worse, but more difficult. On the other hand, as long as you can do test automation, automate deployments, you can probably do it. So there's people doing TDD on mainframes. You can get COBOL in a Docker container now. There's people doing TDD on LaserJet firmware. So if they can do it, probably you can do it as well. When we have too much legacy, okay, well, if you have lots of legacy code, it can be hard to get started with DevOps. On the other hand, there are solutions there. You can start small. Start, for example, with the Strangler pattern and take a small part of the application, wrap something around it, replace this, and then keep moving on. Then my favorite one is, our people are too stupid. Our people are too stupid to work in a DevOps setting. So there's a nice story from a car manufacturer called NUMMI. And NUMMI had a factory in Fremont in California. And this factory was notoriously known for being one of the worst performing car manufacturing factories in the US. So the workforce was demotivated. They were unhappy with their jobs. They were underpaid. They would typically get drunk on the work floor, or they would even put Coca-Cola bottles in the doors of the cars they built, so the doors would make a rattling noise when you would open and close them. So it was not going too well there. So NUMMI, which was part of General Motors at the time, they wanted to close the factory because, well, they weren't making much money there. And then the car manufacturing union, they convinced them to well, basically keep the plant open, but sell it to Toyota. So Toyota came into the factory, and then the union convinced them to hire at least 60% or something of the troublesome workforce there. So Toyota hired them and took them back home to learn the Toyota way and learn about lean manufacturing and stuff. And well, they start caring for their people more than they did before. So they gave everybody a nice uniform, good parking places, good working environments. And in the end, the factory under the supervision of Toyota started running pretty smoothly, and in the end became one of the best performing factories in the US. So after a couple of months, the NUMMI management and the Toyota management came together, and then the NUMMI management said, so yeah, you're doing well now, but the problem was the people, right? And then Toyota said, yes, the problem was the people, but not the people you think. So in the end, obviously, the problem was management, who couldn't create the right working conditions for the workers on the floor there. And Toyota could. So this is where, with the same people in the same factory, they became a lot better performing than they were before. So I think now this factory is used by Tesla to build their cars. So actual reasons why DevOps and continuous delivery doesn't work is typically there's something wrong with the culture. Or even better, there's something wrong with the architecture. And these are things you can change. Changing culture and changing architecture are not easy to change. Typically, it will take a lot of time, but it's possible. So another story about well, flexibility in software. So I used to work for a company that did a lot for government projects. And I came into a project at a time that was already in trouble. So they were behind on schedule. and lots of people were working there, lots of developers, lots of testers, and they had trouble keeping up with all the incoming requirements and changes. And this software had been built as a result of a tender, so like a public project, and it had been designed by two information architects who had the feeling that software was hard to change. So in their experience, stuff that they had worked with in the past, software was hard to change. And therefore, they had designed the system to be really, really, really flexible. So as a result, the system became really, really complex because they had made a design that said that every screen where you could enter data should, in the admin interface, have the opportunity to add extra fields to the screen. So that an administrator could flexibly add extra fields to screens that then the users needed to enter as well on these screens. As a result, the data model was horrible. I remember coming in there on my first day and firing up the application, and it would load slow. And I said to one of the other developers, okay, I know a bit about SQL optimization, so maybe you can get me the query for this page and I see where I can optimize it. And he said, are you sure? And I said, sure. So he went away for 30 minutes and then came back with a stack of paper about this big. And it was like 5,000 pages of queries by a Hibernate ORM that completely went berserk because there were loads and loads of correlations between different classes, and this class would then have a list of this class that would trigger another 1,000 queries, etc. So there was a huge mess, mainly because of the inherent complexity that was there in the design, because of the idea of the people who designed it, that it should be flexible. So then there was this next requirement coming up, and the response of these architects was, well, yeah, we need to make a request for changes for this to see how we're going to design this. And they came with requests for changes, and we ended up seeing this change, and this meant a complete redesign of the entire application. Then we talked to the person who was kind of like the client there, and he said, no, this requirement was the most important thing from the start. So we asked again to the architects, why wasn't this in there? Yeah, well, we kind of forgot about designing this. So in the end, it was clear that there were only two outcomes. We were either going to throw everything away, or the project was going to fail horribly. So in the end, we managed to convince the client that we needed to start over. And with, I think, only 2 people, we got the system live in about 3 months by keeping it really, really simple, but also sitting directly next to the client and their business experts and continuously listening to, okay, what do you need next? What's the most important thing next? Build this, get it live, iterate. And in the end, having really, really simple software that was still flexible because it was only a couple of thousand lines of code. So whenever somebody talks about flexibility, I think back about this period in time where, well, these things happened. So if you think about flexibility, I think it's also about software that's easy to change. So to summarize, how do you work as an architect with the DevOps team or within a DevOps team? Well, by applying the same principles, the same DevOps principles to the domain of software architecture. So that's it. I urge you to now go, please kick some ass. If you want to do any further reading, this is a book I can suggest you read. It has some interesting insights. And obviously, I'm ready to answer any questions you have right now.
So, thank you, Bert Jan. And actually, there are some questions, so I'll just relay them to you.
Yeah.
There's one comment saying, just out of curiosity, your comment about 1 hour working on a proof of concept saves 1 day later on. The question is this something from your own experience, or did you find any research on this? With a smiley, by the way.
Yeah, I think the smiley is sufficient. Obviously, you need to make bold statements to shake up people, right? So it's something from my own experience, and whether it's half a day or 1 day or 2 days, obviously this varies depending on the situation where we are. But I do strongly feel that anytime you spend experimenting upfront will save you lots of time during development.
Okay, thank you. Fair answer. Then another question. Shouldn't the software architect coordinate the architecture between several teams? And how does this fit to the proposed architect in the team?
Yes, it's a great question. So I'd say there are multiple levels of where you can practice software architecture. So obviously, within a team, you need to think about the detailed architecture of the application you're building in this team. But once there are multiple teams that are in some way working together, there's also software architecture necessary over or between those teams, or with integration between those teams. So I'd say that there are a couple of models that you can apply there. First one is every team has its own architect, preferably working in the team. And these architects get together once a week, a couple of times a week, to discuss any interdependencies. Or maybe even before every sprint to discuss any architecture dependencies, or maybe they have an architecture board or an architecture working group. That's one. I think once you become bigger, it becomes harder to get these working groups working. So then one thing that can work is you have one or two central software architects that purely have the task of coordinating work over different teams. So if one team has a problem that they need to solve, then this architect should be the person who says, well, go talk to this other team because they had a similar problem. They solved this in this way. So then you're mainly acting as setting out the line over those teams and acting as glue between those teams. So I'd say that on different levels, you can still act. But I'd say that once you have multiple teams that work together, it's important that obviously there's architecture synchronization. And this can be done either by the architects in the teams by working together, or having by a couple of architects working to serve those teams and connect them, basically.
Yeah, I understand. And another question, can you give some examples of the architecture hindering, or the architect hindering DevOps adoption? The architecture, sorry. So some examples of the architecture hindering DevOps adoption, and what to do about it to fix it.
Yeah, it's a great question. So obviously there's different ways where architecture can hinder a DevOps adoption. If the architecture is set up in a way where there's really specialized infrastructure capacity necessary, so that you need an external infrastructure team to manage and deploy your applications. I say that's where the architecture is hindering you, because you cannot have a team that can deploy and build these applications themselves. Another one could be where there's an external architect outside the team that needs to approve or design all architecture changes. And what happens there typically is that these people get really busy and they don't have time to spend enough time for every team where they're responsible for delivering the architecture for. So then you have this external dependency, where as a team, you cannot move as fast as you want, because the person that needs to basically help you with your overall design of your application is not moving as fast as you want, or is focusing on other things. And I think third, if you have a really big application, let's say that it's a huge monolith with I don't know, a couple of million lines of code where different teams develop on, and it's still deployed as one single deployable. This can hinder DevOps adoption as well, because ideally you as a team are completely responsible for this product or this part of the product that you work on. But if you have one single deployable that 3 teams depend on, who decides when to deploy? Maybe one team is ready to deploy, but another team not. And when one team breaks something during deployment, maybe your part as another team will break as well. So I'd say that this is also one dependency, again, that will hinder you applying those DevOps practices of deploying whenever you want, as much as you want. So a possible solution here could be to see if you can find a way to split up the application so they match up better with the organizational structure, and that every team can be really end-to-end responsible for their part of the product.
Okay, thanks. Another question came in. It says, you mentioned shared responsibility, while at the same time we see the trend of self-steering teams, which I feel make it harder for that responsibility to be shared. Have you also some experience on that, or have you experienced this yourself?
Yeah, I think one thing that's really important is that you can only be responsible for something that you're able to fix whenever it breaks, right? So I've had conversations with basically operations staff when I said I want to be able to deploy stuff in production for my application, so I don't need you to do this for me. And they said, yeah, but if I give you rights to deploy, then you might break stuff when you deploy in production, and then we're on the hook to fix it. But I said, yeah, but if you don't give me access to deploy stuff and something breaks, I can also not fix it. I need to go to you to fix it. So I'm all in for a team that has the responsibilities and also the possibilities to do everything they need to get their application running as well as possible and have all the capabilities they need to do everything from idea to working software in production themselves. So I'd say a team should be end-to-end responsible for the complete life cycle of a product. But then the shared responsibility ideally lives within this team. So this team is one unit of people that have a shared responsibility for this application. Whereas if you share the responsibility with multiple teams or with a team and an external architect, then it becomes harder, right? Because if something breaks or something goes wrong, okay, then who needs to act? Whose fault is it? That doesn't really matter. But in the end, ideally, one piece of product matches with one team, and this team can do everything they need to get this piece of software in production as quickly and as reliable as possible. So I'd say shared responsibilities, ideally within one team.
Okay, thanks. Any questions from the audience here present? Not. I take a last glance at our chat. Don't think there's anything coming. So that leaves me to give you a very, very big thank you for joining us virtually via Zoom.
Thank you.
Next time in person. Thanks a lot. For now, I would say it's 7:45. We'll get a short break of 10 minutes, I would suggest. So we will be back at 19:55, 5 to 8, with our second talk. And that will be the one with Sebastian talking about why testing is so difficult. So see you back in 10 minutes.